Hey everyone, my name is Shruti, and I'm going to be talking with my counterpart Devin about what's new with Snowpark Connect. So let's get started. First of all, we are very excited to go through this feature, and where does it fit in terms of the entire Snowpark story. We're also really excited to announce that the feature is now in GA. So let's begin with a quick overview of Snowpark, of what it is. But before we jump into, for some of you who have actually heard about Snowpark Connect recently, we were in public preview. We are going to be GAing very soon, so please stay tuned. Having said that, let's get into the feature itself. So as you can see, Snowpark over the course of years has evolved as an engine where we are trying to cater to multiple personas. So, for example, if you're a Pythonic developer who wants to use, traditional data frame operations, you have Snowpark. Versus if you're a data scientist or a traditional SQL developers, we have offering like pandas, UDF, store procs to cater to your needs as well. And then there comes the Snowpark Connect, which is GAing very soon, which will let you run your Apache Spark data frame, SQL, and UDF for processing. So let's get into it a little bit further. So a lot of our customers today who come to Snowflake to do their data engineering talk about ton of challenges that they face with their Spark engine, right? So while they love using the PySpark or the Scala Spark technology on the client side, engine becomes a bottleneck, especially with with given the agility of business that they're trying to grow in today's world of AI, right? So when you try to run like open source Spark or like traditional Spark, you have to manage your own security and governance. You run into a ton of performance bottlenecks and scaling challenges, and you have dedicated Spark infrastructure team who is like figuring out which knob to turn in order to get the best potential benefit from the Spark engine. So, what it results into is higher cost, increased governance risks, and slower speed, which means your business moves slow. But Spark also built Spark Connect, and this went recently into GA by Apache Spark community roughly 3 months ago. And what it does is it breaks down the Spark monolithic architecture into a client and server architecture. So, what it leads to from a customer end point of view is now you can run your application IDs, like all your Spark client layer, use Spark Connect API, and send all of that to the Spark driver. So now you have a decoupled architecture where you can scale things like on the client side or on the server side based on what operations you're trying to do. Now, you might ask, why are we talking about Spark Connect here, right? Like, this is Apache Spark technology. Some of you are familiar, some of you might not be, as it is still ramping up. But this gave us a huge potential for us to meet you where you are, and thus leading to Snowpark Connect for Apache Spark. So if you remember the previous architecture where there was a client, then there was the Spark Connect API, which basically sends all the logical plan to the underlying Spark server. Here in Snowpark Connect, we are letting you run the same client layer that you would see with Spark Connect. So if you are on Snowflake notebooks, great. But if not, and you are using Jupyter notebooks, VS Code, Airflow, will great then as well. And as long as you're running Spark data frame, Spark SQL, or Spark UDF, you can send all of that to be executed on the Snowflake engine. So this helps us make sure that you are benefiting from the lower TCO, which comes with the Snowflake engine, and the interoperability, which is empowered with Snowpark Connect, and then improve governance with intuitive and scalable features which come with the Snowflake platform altogether. So let's talk a little bit about the feature highlights here. So where do we stand in terms of our API and language support? Today, in order to use Snowpark Connect, you do need to be on Spark version 3.5 because that's where Spark Connect on the Apache Spark side went GA with, and it's much more stable with 3.5. Anything below, you will need to upgrade to a 3.5 version. We do not support 4.0, it's on our roadmap. In terms of other dependencies, you do need to be on Python 3.10 or 11 or 12. And then from a Java perspective, you could be on Java 11, 17, or 21. In terms of API support, we support Spark Data Frame, Spark SQL, and Spark UDFs today. And then in coding language preferences, we have Python, which is going to go GA soon. Scala is in private preview, it's going to go PUPR soon. And then Java support is coming soon. So, how do you identify what are the right ideal workloads for Snowpark Connect for Apache Spark? So, Snowpark Connect works really great for your ETL pipelines, which are centered around data engineering or feature engineering. As I said, there is support today for Spark SQL, Python Spark, Java is coming soon, and Scala is there. It's in private preview right now. So we are encouraging customers to come to us if they are on SQL, Python, or Scala at this point. We do need customers to be on Spark 3.5.x. Again, it's mostly data frame APIs. You could be using clients like Jupyter Notebook, Shell. You could be using Snowflake notebooks. You could be using Snowpark Submit, which is very similar and wrapped around Spark Submit as well to run your batch workloads too. And this works great if your data is in Snowflake, but also when your data is in managed or unmanaged Iceberg tables too, or in like any third party CSP provider. So we have had customers who had data in S3. We work great with those set of data sources as well. Where it is not ideal is where when you're looking for a complete 100% API compatibility. We have tried to achieve the best compatibility we could get to, but we continue to learn from our through our preview process that we have been running till now. We have seen significant improvements where customers have been able to run their workloads. But again, just to make sure this is not a drop-in replacement, because at the end of the day, you are pushing down to the Snowflake engine. We also do not support RDD, MLlib, or GraphX, just because these do not come out of box for Spark Connect as well. So, what are our customers saying about the product? So, VideoAmp, which is one of our early adopters for Snowpark Connect, used the product, and they just said it worked, right? Like they were able to bring some of their workloads which use traditional Spark. They were able to run that workload using Snowpark Connect with minimal code changes. Booking.com is another one of the early customers or early adopters of Snowpark Connect. They were actually able to run some of these Spark pipelines using Snowpark Connect with minimal changes. And again, for some of their pipelines, they have seen 70% price performance efficiency in terms of the pipelines that they were running on the managed Spark clusters. And this is a quick shout out that the booking.com gave us. Like, as you can see, one of their pipelines, which was running for 1.5 hours using managed Spark, it went all down to 25 minutes. So now that we have talked about what Snowpark Connect is, what's a quick overview, let me hand it off to Devin, who is my tech counterpart, and will be walking you really through how this works under the hood.
Thanks, Shruti. Hi, everyone. My name is Devin Petersohn. I'm on the engineering team at Snowflake, and we're going to take a little deep dive into how Snowpark Connect works under the hood. At a high level, I thought it'd be nice to kind of start with what this looks like from the user's perspective. Shruti, in a little bit, is going to go into an actual demo where she'll show you what it looks like from a variety of different places. But I just thought it'd be nice to show a quick Jupyter notebook. A lot of people use Jupyter, and show actually what it looks like from the user's perspective. And so you'll notice here that at the top we have basically you're importing your Spark session and you're creating your Spark session. The key difference here is that you're just going to basically connect to our Snowpark Connect client, and from that Snowpark Connect connection, from then on, you just continue using PySpark. So you'll notice all the code looks the same. The output looks the same. Everything kind of looks and feels very, very similar. And that's because you really are interacting with PySpark, and what Snowpark Connect is doing is actually all under the hood. So at a high level, this is the architecture of Snowpark Connect. And you'll notice that this kind of gold outlined section at the top, that's running essentially on your machine, and that's running open source Spark. You write your Spark code, and what happens is Spark Connect, which is the open source protocol that we leverage, it sends over Spark query plans to Snowflake, and that's step 2 on this diagram here. Step 3 is where we get to kind of take over, where we interpret the Spark query plan, and then we have a whole host of optimizations and transpiler methods in place to ensure that this executes as efficiently and as quickly as possible on the Snowflake vectorized query engine. So you'll see step 3 here is that we interpret the query plans, of course, and then step 4 is we optimize that query plan for Snowflake execution. After that, we hand off execution to Snowpark, and Snowpark runs these queries on the Snowflake vectorized engine. Now, you'll notice that once Snowflake gets the query plan, Spark is no longer in the picture. We're not actually running a Spark engine, and that's one of the superpowers that we get from Spark Connect, is that we just have to implement the protocol, and we can implement it as optimized as possible. We don't have to bring in an actual Spark cluster on the Snowflake side. We actually can leverage the more than decade of work that's gone into our vectorized compute engine to actually run these things in an optimized way. So I'm going to go into a little bit deeper dive on compatibility. I know Shruti touched on it a little bit earlier, but from the engineering perspective, when we think about compatibility, one of the first things that we need to answer is, how do we test? How do we test whether or not we're correct? How do we test whether or not Snowpark Connect is compatible? Testing here, we basically just took a look at open source Spark tests, and we're effectively using the tests that open source Spark uses for its correctness, and basically going based on that. So our current pass rate is over 85% on PySpark.DataFrame. We are also using all the open source Spark SQL tests, and our current pass rate is over 80%. On top of that, the open source Spark tests are wonderful. They're a great starting point, but there are a lot of corner cases involved in going from Spark to Snowpark that open source Spark developers wouldn't need to necessarily test for. These are tests that we know we need because they're just corner cases that we know exist in the implementation. So we built a whole suite of those kind of corner case testing and correctness testing, of course. And then on the testing side, we also generated a bunch of end-to-end workloads from AI that basically give us a lot of test cases without having to test on our customers effectively. We get all the benefits of kind of running a bunch of end-to-end tests, and that was one of the most helpful things that I think we did in the whole process. On the compatibility differences side, we have all of our compatibility differences are documented at this QR code. They're in the documentation for Snowflake. Just to highlight a couple of things, there are a few types that aren't currently supported. One of the examples that I have here is daytime interval type. Take a look at the link at the QR code if you're interested in more on that. And then on the unsupported operations side, I wanted to flag repartition here. And repartition is something that people often do to rebalance partitions, or they do it as an optimization step. Because Snowflake is already optimized and already optimizes its partitions, you don't need to manually repartition your data for performance. You are still free to, of course, do a partition by, or any of the kind of logic-based partitioning that you might normally do in Spark, in like a Spark workload. But you don't need to go in and try to repartition or rebalance your data. Snowflake actually does that automatically for you. And with that, I will hand it back to Shruti, who's going to walk us through a couple of really awesome demos and show us what it actually looks like in action.
Thank you, Devin. That was a great technical deep dive. So let's get into Snowpark Connect demo real quick. I'm going to pick two scenarios. I'm going to actually show you Databricks Notebook, which is doing bunch of data frame transformation operations, and then we will have the same code and we'll show it to you how it runs on the Snowflake notebook side of the house. So that being said, let's jump into the Snowpark Connect demo. As you can see, I am in my Databricks environment, and this is a simple operation where I'm like trying to start where I'm starting my Spark session. I'm doing a read from a table that is already there in Databricks. I'm doing show operations, some select, filter, group by operation. Here I've taken a case of like, okay, now I have customer data. I want to understand what their monthly spend looks like, what kind of subscription type do they have, and I'm doing show group by filtering operations, and then I'm writing that data back to a table within Databricks as well. As you can see, I have run this code, and I can rerun it, and it runs rather quick, and the output is right here. Right. So if you look at this code again, just to make sure that we have all taken a look, this is starting the Spark session, reading from a table that's in Databricks, loading that into data frame, doing show operation, doing a select, filter, and a group by operation. So now let's do a transition to a Snowflake notebook. So this is the Snowflake notebook that I have. So, as you remember, I walked you through a light transformation process on the Databricks notebook. Now we are going to talk about running the same code, data frame in Spark SQL code, but on Snowflake notebook using Snowpark Connect. On the packages side, the first step is to make sure that you have the Snowpark Connect package right here, which is using latest version. I've created this notebook with Python 3.10, so works great. And as you can see in this notebook, the changes that I've done is around initiating a Snowpark Connect session and then making sure that I'm calling the right PySpark libraries. So if you remember in my previous notebook, I was actually reading the data from a Databricks, like Unity catalog table, and I'm doing something similar, but here I'm reading the data from a Snowflake table, loading into a data frame, and then just like how we did the same operations as df.show, figuring out whether the subscription tires for different customers and doing group by operations. I'm doing everything similar to that particular Databricks notebook. And if you really want to make sure that that's one-to-one code that I was showing the Databricks notebook, you can see right here that I have the table name, which is basically loading the data from my Snowflake table. I am loading it into a data frame. I'm doing df.show. So just see here, I'm doing df.show, df.show, df.select. I have the same code right here. Then I'm doing filtering operations. As you can see, I'm doing filtering operations here as well, and so on and so forth, right? Like I'm doing group by operations, and then I am writing the data back to Snowflake. And as you can see, I can run the same work, same notebook, and it will generate the same set of results that you saw on the Databricks side as well. So I hope you enjoyed the demo. We kind of, in summary, walked you through what the feature is, Snowpark Connect. How does it fit into the entire Snowpark ecosystem, which is evolving to cater different customer personas? And then what is really the benefit, where the benefit being that you're able to bring your Spark workloads and run it on top of Snowflake engine, thus benefiting from the great price performance that you get out of our engine. We walked you through how it works, did a technical deep dive, and showed you a comparison with a Databricks notebook where we were doing very lightweight transformation, and then did the same with the Snowflake notebook as well. So now, if you're all excited to, further embark on this journey of Snowpark Connect, first things first, you will want to run SMA, which is our Snowpark migration accelerator tool. You would need to go through the code assessment piece, not necessarily the code conversion piece. So when you run SMA, the first step would be to upload your directories, or the files, or notebooks. Run SMA assessment that will help us understand how compatible your workload is with Snowpark Connect. Usually we have high compatibility and coverage with for data frame and Spark SQL workloads. Anything else, let's say if you have RDD or anything other than like data frame or Spark SQL, for example, if you have Spark ML, then work with the account team. We'll make sure that we make you well supported through the process. If you want to try out the product just from a trial perspective, we do have quick starts guide and documentation available. Like you can use quick start guide to run a simple workload using Snowflake notebook. If you want to go a little bit further, you want to use your own Jupyter notebook, or you want to use Snowpark submit, all of these workflows are today documented on our documentation website as well. You can just search for running Spark on Snowflake, and that will take you to the documentation. So that's all that we had for today. We really hope you enjoyed the demo as well as the product walkthrough. Please get in touch with us if you have any questions, and we are looking forward for you all to try out the product. Thank you.